Did everyone here attend the keynote this morning? It's out of curiosity. See, most hands are raised. Okay, good. So what we'll be doing is covering a little bit of what we covered in the keynote, but also diving into a bunch of other stuff, and also giving you a bit more background and context on what it is exactly that we're doing here in the cloud-native space. Now, I've given a number of talks today and yesterday. I'm reusing some slides. So if you see some slides initially that look the same as the talk you've already seen, well, don't fret. There's actually a bunch of other different stuff coming after that. All right. So let's get started here. And I wanted to get started by talking about the why behind this cloud-native apps phenomenon. Containers, microservices, DevOps. Why is there so much noise about this in the media? And what is exactly are we trying to get to and accomplish with all this stuff? So, it's interesting to talk about some examples. Start with John Deere. Now, John Deere is a company that's blogged about this transformation that they made, as well as folks have written some studies on them. And I think, if you know John Deere, right, they do tractors and combines and these sorts of farming equipment. And it used to be that was the value that they delivered to their customers, right? They made a great tractor. The thing lasted a long time. It ran really well. Does whatever good stuff tractors are supposed to do. I don't know. But anyway, people loved them, right? But as we get more to this mobile cloud era, the value of what they deliver to their customers is actually changing. Because it's no longer just the tractor itself, right? It's actually the sensors that are on that tractor and all the data those sensors can collect about the underlying soil, about what's been planted there, so on and so forth, phosphate levels, this sort of data. It's about the ability to then shoot that information up to the cloud so you can then perform big data analytics on it to understand better about how to maximize the productivity of your land. That's really the value that John Deere is now giving to their customers. It's not a great tractor. The tractor is the vehicle, right? What they're really providing is maximizing productivity of the land. Really, farmers can start looking at this as more of like an ROI, right? What am I getting out of this purchase that I'm making? And you can imagine this is a really big transition for a company like John Deere, someone who's very focused on sort of this mechanical engineering aspect of building out tractors. They now need to develop this whole new aspect and specialty around IT and this great software analytics platform that runs in the cloud. And you can certainly imagine if they were not able to make this jump, if they stayed just focused on making awesome tractors, then you'd have a competitor that would come along eventually who would make a decent tractor, probably an okay tractor, but then make an awesome analytics system on top of that, and then derive much more value, right? And actually, over time, disrupt John Deere. But what actually happened was not that, right? John Deere really took the bull by the horns and made that transition. And so what you see now is some really, really cool stuff, right? We talk a lot about self-driving cars, but here it's like, all these machines are self-driving, right? They all have GPS, they know where they're going. They can measure to within a square foot the amount of fertilizer they put down and then the amount of yield from that land, right? So they can do all sorts of experiments across the land and see how they can maximize productivity. And then they built, as I said, this whole software analytics platform on top of all that. And this integrates with all the different tractors and equipment that they have. And so really, it's kind of funny because the farmer is slowly transitioning from this guy who used to do a lot of manual labor, in the hot sun, to this dude who sits in basically a NOC controlling all these autonomous vehicles, right? Doing stuff, collecting data. He kind of becomes a data scientist even. And, John Deere has been very successful at this. They've built out a platform, as I said. Now they have a bunch of third parties, a bunch of partners who are writing applications on top of that platform, on top of all the data these farmers are collecting about their land. And they can make intelligent decisions and so forth and do cool things based on that. So again, this transition, this business transformation that occurred there from mechanical engineering to software engineering, and that type of disruption that they had to avoid. So let's talk about another example. This one's a bit closer to home for me. When we moved into our current place about 4 years ago, the previous owner had these speakers all over the house, and I had wired them all down to the basement. Now, I am a lazy person. I'm not going to go down to the basement to start playing music. It's just way too much effort, right? So what I want to do is research and say, okay, how can I control these speakers from my iPhone, right? Make it super easy for me to do this. And so I Googled, and sure enough, I found these guys, Sonos, right? And their amp. And then I researched, okay, does it support, all the services that I like, Pandora and Spotify? Can it connect to my Mac and my Windows PC? Can it play music off my phone? Blah, blah, blah. All those things you look for. Sure enough, it could. So I said, great. I bought it, and, I was a happy customer. Now, I didn't really think about this at the time, but I realized this, reflecting on it maybe a few months ago. There was one thing I actually never did any research on when I made this purchase, and that was audio quality. Isn't that a funny thing? Here I am buying an amplifier, and yet audio quality was not top 5, not even top 10 in my list of considerations. Right? I didn't even think about it. My focus was all on ease of use. So again, here's another example of a company who probably previously defined their value to customers as making a great audio product, right? Great sound, works really well in all different sorts of rooms, so on and so forth. That was not my concern, right? My concern was purely ease of use. So again, we're starting to see how companies across different industries, right, audio and John Deere tractors, they're having to think very differently and offer actually a different value proposition to their customers than they traditionally have. I mean, again, with Sonos, it's like, even their name is sound, right? And so here they are. The value for me is not the sound, it's the ease of use, it's the software, it's the fact they continually update the iPhone app. They make it so easy to update also the Sonos amp software. Really, really great customer experience. So that's really what we see driving a lot of that. Now, the reality is that IT has to drive these changes. These are not easy changes to make. These are some very, very challenging and deep changes to an organization and to the technologies that you use. But what you can see here, this is a report from Puppet Labs. What you can see here is that the difference between a high-performing IT organization in this model and a low-performing one, it's stark. Right? You can see 60 times fewer failures for high-performing organizations, much, much, much faster recovery time, many, many more frequent deployments. And the last one, this lead time, is something that I think is particularly interesting. Lead time is talking about once you make a decision, a business decision, to say, yeah, we're doing this, we have this idea, let's go implement that. How long does it take to get that idea into production as running code? Right? What's that delta there? And what this thing is showing is that the highest performing IT organizations do this basically 200 times faster than the lowest performing ones. Now let's think about that from a competitive position, right? Both these guys, maybe they have both good business people, they both see the idea, they both see this opportunity in the market, but one of them has a better performing IT organization that can get those changes out to production 200 times faster than the other one. I mean, who do you think is going to win between those two companies long term, right? So, I think what we're seeing is this transition from IT being kind of this cost center, right, trying to reduce costs, which, by the way, was a lot of what, the original virtualization drive was about, reducing CapEx. What we're seeing is that changing, actually, to become now, IT is now focused, the point of IT is to focus on top-line revenue, right? Not bottom-line savings, but top-line revenue, driving greater engagement and interactions with users and customers. So IT is now really going to be viewed as more of a center of innovation and differentiation for businesses. This is the sort of change that we're starting to see. And so the challenge is, how do you go and implement that? How do you think about that? And I think this is exactly what DevOps is trying to do. When you hear the term DevOps, people are trying to go and do that. A lot of that is trying to create that high-velocity organization. That oftentimes means breaking down walls, breaking down silos within the organization, looking at this problem as a real end-to-end problem between idea generation, running code in production. Those are the two ends. Everything in the middle is implementation detail that needs to be optimized. Now, it's important, don't get me wrong. Just because I said it's a detail doesn't mean it's important. But we should all be focused within an organization on how to drive speed, from that one side to the other. And that's really what DevOps is focused on. Now, DevOps is many, many things. It's primarily cultural, organizational, philosophical. There's a mindset to it. But there's a lot of technical pieces that are brought in there as well. So for this discussion today, I just had a talk at noon. We have a whole DevOps at VMworld thing. And for that one, I focus a lot more on the culture and the mindset and the philosophy behind it. But for this one, I'm going to do a little bit different. I'm going to focus more on the technology. Because you need both pieces in order to be successful here. So really what we've been focused on at VMware is providing a pretty comprehensive view of this life cycle and of this process from idea to running application. Now, I'll be the first to say that this is not, we're not trying to do everything, right? No one company, no one person, no one organization can do everything. But we think we have a lot of value to add in different areas of this process. Let's just walk through this real quick. So we have on the left-hand side there the developer laptop. This is where code is written, right? Someone has an idea, start developing some code, start testing it, and so forth. Now, as that code gets checked in, it goes into the continuous integration, continuous deployment process in the middle there. And that's really leveraging a lot of different tooling to automate that, the build, the test, and to really scale that out. Finally, on the right-hand side is the production stack. Once the code has been tested, it's ready to go, it's packaged up, then you can push it out into production and actually deliver that to your customers. So again, the focus here is really about how do you get the right sets of technologies to really optimize this whole process from left to right so that you're doing it continuously, you're constantly pushing out new changes to production, if you want to. So some regulated industries aren't able to do that as well. But the idea is you should be able to do that from a technology perspective. Technology should not be holding you back here. Okay, so for this talk, we're really going to dive into each of these different areas and talk about the things that VMware is doing. So let's start off with the left-hand side here in App Catalyst. So App Catalyst is relatively new from VMware. We actually announced it and released it about 2 months ago. So the point of App Catalyst is really focused on developers and really optimizing the developer workflow on their desktops. So it's a free desktop hypervisor focused on developers of next-generation applications, largely, in this case, Linux-based. Now, initially, this is out there for the Mac. We will, of course, release a Windows version. So what this looks like in slightly more detail is, again, the core VMware hypervisor technology packaged up in a very simple form factor. What we've done is we've actually taken Photon OS, which, as I announced in the keynote today, is a lightweight container-optimized Linux distro, and really baked that in there. Kind of like what we're doing with Photon Platform, or Photon Machine, as you heard earlier today in the keynote. We're trying to combine the notions of a hypervisor and an OS to really just simplify the whole process. We don't want people to be having to manage VMs. We want people to be able to run their applications, and the VM management can just get taken care of. This is exactly what App Catalyst does. So we've put on things like CLIs and APIs, the things that developers like to use. In fact, App Catalyst has actually no UI. So things like Vagrant, Docker Machine, these are the types of technologies that developers are really starting to leverage for next-gen workloads. So again, App Catalyst, very simple. It's really meant to help developers accelerate the build, test, run, debug cycle on their local laptops or desktop machines in their development environment. Okay, so that's App Catalyst. And again, there's a link on the previous slide. It's getappcatalyst.com. So please go check it out, download it. It's free to download, free to use. Okay, so now let's move along into the development lifecycle. So this is really talking about the continuous integration, continuous deployment space. Now, as we just mentioned, and I want to kind of hit on it again, but when you embrace this kind of DevOps mentality, it really helps to separate out the high performers from the low performers. Again, this is more stats here essentially, and again, more shocking numbers, right? 8,000 times faster in completing deployments. I mean, you can just see the benefits that are here and the agility that you can get out of fully embracing these types of technologies. But there's a lot of challenges here, right? And so if we look at a traditional type of continuous delivery methodology, you have development happening on the left-hand side, people coding, people branching, doing agile development, continually pushing stuff out there and getting feedback on it. And then it'll go through a set of tests, unit tests, user acceptance tests, staging tests, so on and so forth. So you get a bunch of small releases going through this pipeline. That pipeline consists of these different testing infrastructures, right, all the way out to production. Now, what we see and what we commonly find is that a lot of this process around moving that code from the left to the right-hand side is very manual, right? That code will run in a testing environment, and you'll see a certain number of tests pass, and you'll have some sort of release or build engineer say, okay, well, did that pass enough? Can I move it on to the next stage of the pipeline? They'll make some sort of decision based on that. And eventually that code will, over time, get pushed out to production. But I think really what we're looking to do is how we can better automate this whole life cycle. Now, as part of that challenge, though, as part of the automation challenge, you have developers wanting to push a lot of stuff out, right? This is what developers like to do. They like to move quickly, push a lot of changes. They're not necessarily thinking about all the security and operational sort of concerns that operations teams are. Now, operations kind of want something else. They say, you know what, I don't want things to break. I really want things to be stable. So again, this is kind of where DevOps comes in the middle, which is that you want to be able to automate while at the same time providing the right level of governance and policy over what you're automating, over this underlying pipeline here. So as you think about this pipeline and how to automate it, this is exactly what we're focused on with vRealize CodeStream. It's all about accelerating that whole process there in the middle, right, of going from the code to something working and ready to go out to production. And so what it does is essentially takes all those steps that we saw on the previous slide and figures out how to automate the movement between those steps. So you can, first of all, define that pipeline somewhere explicitly. Again, you saw in the previous slide we had these lines kind of connecting the different environments. Today, actually, that doesn't really exist generally. It exists in people's minds or maybe in a document somewhere. It doesn't exist programmatically anywhere. These are all just discrete sets of infrastructure that happen to be used in a certain way. So what CodeStream does is say, you know what, no, actually, this infrastructure, that infrastructure, this infrastructure, these all connect together to form a pipeline. You can then put rules around how change tests move through that pipeline. How many tests do they need to pass? Do they need to pass certain tests, or is it just a percentage? Or maybe in some cases you actually do need someone to go in and manually approve that thing to go to the next stage of the pipeline. But generally speaking, the point of CodeStream is to be able to define that automation and then to get a lot of feedback on that automation. You can get data on how many of the tests are failing, where are they failing, who's causing the most failures, right? Are there certain modules that might have bigger problems than others? So on and so forth. So we see CodeStream as an enabler of all these technologies. And to be clear, CodeStream is not trying to be competitive with any of these technologies in the space like Jenkins or Bamboo or Chef or Puppet or any of these other things, right? CodeStream actually automates the use of those tools and technologies. So again, a pretty cool new product. There's a bunch of talks here at VMworld on it, so I encourage you to definitely check that out. All right. So now I'll start getting onto the right-hand side, the production stack. Now, as part of this, before I get into the actual infrastructure side of this, I actually want to focus on the applications for a minute. So applications are changing, and they need to change in order to get the sort of agility and speed that we want in this next generation world. So what we're really talking about here is moving from more of a traditional monolithic type of architecture to something called microservices. Now, microservices is a bit of a buzzword, right? But it really talks about any sort of distributed architecture, service-oriented architecture. A lot of these things have conceptually, the same thing. Now, in a monolithic architecture, what you have is a bunch of different components of an application that are all effectively statically linked together, all part of one binary inside the same process. This makes it pretty challenging to update these things because a lot of times they don't have very clean APIs. You update one piece, you break another, it gets kind of challenging. This is what results in this whole giant sort of war room thing over the weekend when you want to push an update out to production. You need to get everyone and their brother in the room, do that, push it out there, cross your fingers, hope nothing breaks, but of course stuff does, and you got to scramble to fix it as fast as you can, right? It's not much fun. Now, in a microservices architecture, we're doing something different here. Here what we're doing is breaking down the monolith into a discrete set of individual components, each of which has a very specific purpose. Right? You might have one thing that does authentication, one thing that does logging, another thing that does some sort of business logic piece, whatever it is. And now, each of those components have a well-defined interface, and they assume a network connection between them, so using REST APIs to communicate. Now, what this enables is separation between these components, and that enables a lot of freedom. So each of the application teams developing these components can use whatever frameworks they want, whatever languages they want, right? It's each of their choice. No one else should care because everything's hidden behind that well-defined API. Similarly, if one team wants to go and push an update, they don't need to tell anyone else. They just push the update. So long as they're not breaking their API, which they shouldn't be, and the testing should prove that, right? As long as they're not breaking the API, no one else should even notice. So when you think about driving speed, you think about driving rapid updates into production, this is the type of model you need. You can't get everyone in the room every time you want to push an update. If you want to push an update multiple times a day, you have to let individual engineers or engineering teams make that decision of their own accord. But then, of course, you have to all the right testing and so forth to make sure that change will actually work. So that goes back to our previous set of slides, right? So that's the microservices architecture. Now, there's also trade-offs, right? They talked about the benefits. There's also trade-offs to these architectures. Probably the biggest trade-off with microservices is that running a distributed application is just harder than writing a monolithic app. The reality is you have to deal with a lot of challenges of distribution, partial failure scenarios, a lot of weird things that can happen. And you got to kind of rack your brain to think through how to survive and recover from those sorts of partial failures. So I don't think that microservices is a panacea. It's not the right thing to do for every application. Right? A lot of the applications that you have, probably just fine to leave them as monolithic. Where you really want to focus is the applications that differentiate you as a business. Right? Again, think back to John Deere. That analytics platform, hugely differentiating for them. They absolutely wanted to go on a microservices path there, right? Because they want to move as quickly as possible. However, some back-end HR system or whatever it is, not really differentiating them, it's just there because they need it. Leave it as monolithic, right? If there's no problem with it, don't reinvent the wheel. So again, I think when you're thinking about application design and architecture, really tie it back to business goals. If you think that this application or product will be a huge differentiating factor for you and really drive innovation with your customers, then definitely move to microservices. If not, keep it as monolithic. Okay, so everyone's going to have a few of these microservice apps then, things that meet the bar for going microservice. Now, when you do that, you need a certain set of, let's see here we go, certain set of capabilities in order to run that. And that's really where platform as a service has come from. Now, platform as a service has been around as a concept for many years, right? It's kind of one level above, if you will, infrastructure as a service. Now, with infrastructure as a service, you can go and get a VM. Now, that's great. You get your VM, but then you're kind of on your own. You got to install an OS in there. You got to install your app. You got to manage it. You got to patch it. You got to configure it with networking. You got to deal with security issues. You got to figure out, how to isolate processes within your application, so on and so forth. A lot of problems to go and figure out, right? So platform as a service came along to help answer and solve a lot of those problems in a very easy out-of-the-box solution. Things like Heroku and Google App Engine are actually offered as services, making it very, very simple. And then, of course, our own cloud Foundry as well that VMware helped to create back in 2010. Now, this guy Brian Gracely put out a blog on Wikibon a couple of months ago, and it really talked about this distinction between structured and unstructured application platforms, or structured and unstructured PaaS. And I think this is a really important way and a really good way to think about the differences in these application platform as a service architectures. So let's talk about structured first. Again, structured were the traditional types of platforms as a service. Again, these things came out of the box. Everything was there. It just worked. All the logging and monitoring and scaling and routing and service discovery and scheduling, all that stuff baked in, just works. Flip the switch, you go. That's great, right? Downside? Well, it's fairly opinionated. In order to enable that seamless integration, they have to make some design decisions of their own, which force certain decisions on the application. So that means that the decisions they make may not map exactly to how you want to do things, right? So generally speaking, structured out of the box, very easy to use, but somewhat opinionated. Unstructured, on the other hand, really takes this picture on the left and says, you know what? Instead of one vendor coming in and stitching this all together ahead of time, let's look at the hundreds of startups in this space, all focused on different areas of this graphic here. And what you can do as a business, as an IT shop, is really take the best of breed components you find for each of these things and stitch them together to create effectively your own platform as a service. That's the unstructured approach. It's the DIY approach. Now that's good because you get exactly what you want, right? There's no opinionated thing that doesn't work for you. You can design it how you want for the use cases that you have. The challenges, though, are that this can be very, very time-consuming. A lot of these technologies out there are still very new. They may not be very mature or proven in the enterprise. A lot of them may have rough edges. A lot of them may not integrate very well. So, you look at the structured approach, everything out of the box, it just works, but has opinions about how things should be run. Unstructured has no opinions whatsoever. You create them yourself, but has a challenge of how do you actually stand that up and get it running in production with all the sort of service levels that you expect and require. So let's dive into each of these two areas here in a bit more detail. We'll start off talking about the structured platform side. So on the structured platform side, we have Pivotal Cloud Foundry, or Cloud Foundry more generally, but Pivotal Cloud Foundry specifically. We're really excited about PCF. We, as I said, started Cloud Foundry back in 2010 within VMware. When we spun out Pivotal with some of our assets, Cloud Foundry was part of that. And they've really taken Cloud Foundry and run with it and really built what we feel is the best enterprise solution for cloud-native applications. So as you can see here, there's a bunch of technologies and pieces that go into it. It can run across the cloud of your choice and really designed for speed, scale, and agility. Now, let me touch on the more general Cloud Foundry really quickly before diving into some of the specifics of PCF. So one of the things that Pivotal did after taking on Cloud Foundry was to it was actually already open source, but was to create a foundation, open source foundation around Cloud Foundry. So they actually gave up any rights to this foundation. Now, this foundation, as you can see on the right-hand side, has a lot of members, right, representing about $1 trillion in total market cap. So a lot of very large companies have their full weight behind Cloud Foundry. And we're really starting to see that play out, right? We're seeing a lot of traction with Cloud Foundry in many different customer accounts. Pivotal themselves announced that PCF's on about $100 million a year run rate and growing very quickly. We have folks like IBM doing Bluemix. Bluemix is based off of Cloud Foundry. HP, Helion, and many different others are all basing their technologies on top of Cloud Foundry. So really, really exciting to see all that happen, and a lot of the innovation that's continuing to be driven into that foundation. Now, with PCF in particular, there's a few core areas that they're kind of focused on. The first of which is developers, making this very easy for developers to use. So developers essentially build their code and send their code to PCF. PCF takes care of compiling it, getting it all ready, packaging it up, putting it into a container, doing all this nice stuff, and it just kind of works, right? So as part of that just works notion, there's also the operational aspect of it. So here you have all the dynamic routing and auto-scaling and health monitoring and logging and so on and so forth. A lot of these different things that you would expect out of as I said, a platform as a service, right? Finally, you have ecosystem. And this is something that's particularly interesting because anytime you build an application, you really want to focus on your business logic. Things like storage and whatever, you want to leverage an existing building block that's already there, something like Redis or MySQL or Mongo or whatever have you. So when you're provisioning the application, you don't just need to provision the parts that you wrote, you need to provision all the different services that application needs as well. And so PCF handles that for you completely automatically. You explicitly define your dependencies. And when you push out your application, PCF will automatically create instances of MySQL, of Mongo, of Redis, of whatever you need, and then connect those things back to your application. So again, handling all that for you automatically. So I think that's one of the kind of core ideas behind PCF is that a lot of it is just automatic. And again, it works out of the box. That's the whole idea of this structured application platform. It's just really easy. It's turnkey, right? Okay, so that's PCF, and I'll skip over the architecture bit there. Now, on the other side, the other side of the coin here, the unstructured approach. The technologies you probably may have heard about, things like Docker, Kubernetes, Mesos, Lattice. Lattice is also part of Cloud Foundry. So Cloud Foundry also has kind of an unstructured approach as well as a structured one. But let's dive in here and see what these unstructured approaches are really all about. So they all start from Linux. Right, or Linux. Whoa. I've given a lot of talks today, sorry. Linux containers. They all start from containers. And this kind of renaissance of containers that we're seeing is driving a lot of innovation in that space. Now, containers have been around for a long time, for decades, in fact. Solaris has them, FreeBSD has them. And of course, they've been built into Linux over the past 10, 15 years, right? And Google has used them extensively. They talked or blogged just recently, a few months ago, about how they're provisioning 2 billion containers a week on their production infrastructure, right? Now, what Google really leveraged containers for was simplifying operations at scale. Containers for Google, and actually for most uses of containers historically, they were not developer-centric. They were operations-centric. It was the ops teams who were leveraging containers in order to really simplify how they ran at scale. Because what they saw that these containers do is provide basically a very nice, reproducible environment for that application. That meant wherever they're running it, whatever sort of infrastructure, that application always saw the same thing. It was very easy to scale that up. They didn't have to deal with all some of the configuration management and so forth types of issues. Now, as we all know, though, today, containers are all the rage because of developers, right? And the reason that that happened was because of Docker. So Docker found a really innovative way of working containers into the application lifecycle development process for applications. It made it super, super easy for developers to package these applications up to get their work done. You can imagine that whenever you provision an application, traditionally, into an operating system, you have to do a lot to that OS to get it just right. You've got to configure the libraries that are there, the versions that are there, all sorts of other things, and make sure that everything's just right so you can put the application in here. With containers, you don't need to do any of that, right? You just do Docker run. Basically, the container just starts running. That container has everything it needs inside of it to run that application. You don't need to worry about all the sort of stuff that goes around it. So that's really the idea behind Docker and containers and why it's so interesting. Now, as we're seeing here, though, there's a bunch of stuff happening in the startup world out there and from established companies. Folks diving into that platform as a service diagram I showed you earlier and tackling different problems within there. So a lot of folks, looking at cluster scheduling and sort of management, folks looking at the operating system side, folks looking at infrastructure provisioning, folks looking at the basic container piece of it, folks looking at the network side, the storage side, goes on and on. This is not meant to be a comprehensive list of the different companies out there. I just started Googling, and for the first names I thought of, found their icon, put it here. So there are hundreds of these guys out there, right? We talk to a lot of different ones. We see different ones at different customers. So this is both the opportunity and the challenge. Opportunity, a lot of great technology out there, a lot of very passionate people in this space. Challenge, a lot of this stuff is still brand new. Right? A lot of these guys are still tiny startups. This stuff hasn't been proven yet. Also, a lot of the integration that you're going to need to do between all these different technologies may not yet have happened either. So a lot of times you'll be kind of the forerunner in that area, which, again, can be both a good and frustrating thing. So in any case, as I said, there's really two different approaches here. The structured approach, which you just mentioned with Cloud Foundry, and the unstructured approach with all these great technologies, really looking for you to build that together yourself in the way that you want. Okay, so now let's move down to the infrastructure level. Okay, we talked about the left-hand side there in terms of developers, how they're pushing out code. Then the development lifecycle piece to automate the continuous integration and deployment. We talked about application, how application architectures need to change. But of course, infrastructure is still really, really important in this whole thing, right? So let's dive in and talk about what we're doing here. Now, a couple of updates for you in case you haven't been watching over the past few months what we've been doing. So back in April, we announced something called Lightwave. What Lightwave is really focused on identity, authentication, certificate management for containers and cloud-native applications. So we felt that there was a kind of a gap in the marketplace here, that we really had an opportunity to help drive identity and security in the container and cloud-native app space. This is exactly what we're doing with Lightwave. So it's an open source project. You can find on GitHub, and we're continuing to drive it, but we'd encourage everyone to collaborate with us on it. Send us code, talk to us about it, test it out, so on and so forth. So again, a really great component there. Now the other thing which you've heard me mention already is Photon OS. So again, we released this one back in April as well, and it's also open source on GitHub, so you can go and check it out. Now, Photon OS, as I said, is a container-optimized Linux OS. And let me tell you about why that's important, what that means. So if you look at traditional Linux operating system distros, right, you find that they're oftentimes, when they're installed, many gigabytes in size, like 4, 5, 6, whatever gigabytes. The reason for that was that these operating systems, versions of Linux, needed to have a bunch of packages provisioned with them because applications needed different things, right? So you want to have enough kind of critical mass of packages that you could deploy your application and things would mostly work. But as we said, the change with containers is that everything the application needs is now inside the container. That means that 4 or 5 gigabytes of libraries and components that have been provisioned aren't really necessary anymore, right? There's no reason to have all that stuff. Instead, what you can do is have a very lightweight Linux distro with just the minimum amount of stuff needed to run a container. That's exactly what Photon OS is focused on, a lightweight, container-optimized Linux operating system from VMware. Now, out of the gate, we want to be very expansive in our support for all the different technologies out there. So we have support for Docker, for Rocket from CoreOS, and for Garden from Pivotal. There's also this whole open container initiative that's going on that we're a part of as well. And as those things formalize, we'll, of course, add support for that as well. Now, the idea with Photon, as you heard, is kind of to build it into vSphere, build it into Photon platform, and to make it just a seamless part of that whole operation. And so, as part of that, we're going to be optimizing Photon OS to really run best inside of a vSphere VM, super, super lightweight. And finally, as I said, the idea is it all comes from VMware. You kind of have one throat to choke, this notion of one phone call to make to us. Our goal here is not necessarily to monetize it directly, but really to add it on as part of the infrastructure you have with vSphere. So again, it's open source. It's out there. We encourage you to go out, check it out, and take a look. Now, let's review the updates from today. So the first thing we announced today was something called vSphere Integrated Containers. And as you heard, the point of vSphere Integrated Containers is really to make containers a first-class citizen inside of vSphere. The problem today is that IT operations doesn't have visibility into the containers that are being provisioned inside the VMs they have on their private cloud. So vSphere Integrated Containers enables that type of visibility. It does that by actually virtualizing the container host. So I'll talk a little bit more about how that works in the next slide here, because there's some interesting subtleties there I want to get into, which are, in my opinion, very cool. But the point here is that once containers become a first-class citizen, then you can go and apply all the great technologies we have in vSphere to those containers. Again, we saw NSX and vSAN working on the container today that we had in the demo and the keynote. But DRS, vMotion, HA, all the scripts and tooling from all the partners in the Solutions Exchange out here, all this stuff, just works with containers now, with vSphere Integrated Containers. And the point here is that you don't want to have to get new tooling. You don't want to have to retrain your operations folks. Instead, you can take the existing tooling, their existing knowledge, and start immediately operating on containers. We think that's really, really powerful. And similarly speaking for the developers as well, right? The developers, as we saw, were still using that container interface in the demo. It was Docker, right? Just regular Docker API. That's what they know. That's what they do. They don't need to know vSpheres behind the scenes. They can do what they want. So it's pretty cool, actually. vSphere Integrated Container sits in the middle. It enables the IT ops folks to do what they've always done using their existing tools. It enables the developers to do what they've always done using their existing tools. Again, that's kind of the best of both worlds that we talked about, right? Giving the portability, speed, agility of containers to developers, while at the same time the visibility, security, management to the IT operations folks. Okay, so now let's talk a little bit about how exactly this works. Okay, so there's a before and after. So now, in the beforehand, on the left-hand side here, the way this works today is that either the admin can provision a VM to the developer, or if the developer has the appropriate permissions, they can do something called Docker Machine. Docker Machine talks to some endpoint, could be AWS, could be vSphere, could be whatever, and will create a virtual machine with the Docker engine inside of it for that developer. That virtual machine exposes a remote Docker API the developer can then call to go and provision their containers. So we can see the containers pop up in here. Okay, there we go. Now, again, very simple workflow. Docker Machine creates that VM. The VM has a Docker engine kind of pre-installed as part of it. That Docker engine exposes the API. The developer uses the native Docker API and then goes and provision containers. This is the normal workflow. But again, the problem here is that those containers are hidden inside the VM, so all the existing tooling doesn't see them. That leads to all the problems that we talked about. So what we're doing in vCenter, vSphere Integrated Containers is a little bit different. So now, again, what we do is the VI admin will create what's called a virtual container host. That virtual container host creates a resource pool inside of vSphere. This resource pool is what you would call, again, a virtual container host. So the VM on the left-hand side is the container host. It's a VM. It could be a physical machine as well. That is one specific unit of compute. What we're doing is virtualizing that. So no longer is it one specific set of compute. It's now an aggregated set of resources inside a resource pool that can be run anywhere. The first thing we create is this tiny VM called, that runs the Docker engine. And it says UVM there, it's supposed to be micro VM, but the concept we actually went with is just enough virtualization. So it's a typo on the slide. So in any case, we have this very lightweight VM we provision the container engine into. That container engine provides the exact same API as on the left-hand side here, right? So the developer can go use that just like they always do. Now, that Docker engine has a little asterisk next to it because we modified it to actually talk to vCenter instead of talking to Linux to create containers. Now it talks to vSphere and says, hey, vSphere, go create a VM for me, and I'll put that container in there. And that's exactly what vSphere does. And it does that, as we talked about earlier, by using instant clone. So what we'll do, and the way this works, is to actually have a pristine Photon OS VM running. We boot it up. It's 25 megabytes, super lightweight, right? Once it's booted, without any apps running, we freeze it. And then, as these container requests come in, we'll fork off that VM to create an identical clone, which we then customize, IP information and so forth, and then inject the container into. You can see in the bottom right-hand corner there, all these layers. Those layers are the Docker image layers. We map that into an image, into a VMDK or a set of VMDKs. We hot add those VMDKs right after the instant clone. So now what we've done is create a VM with the right application inside it and with any data volumes that that application may have. So this is pretty cool, right? Each of these little boxes within that blue circle there are an individual VM, but super lightweight VM that are all sharing memory, right? So they're created instantaneously, less than a second. And when they're done, when the container is done, we just kill the VM. So I want to talk about this for a sec, because this is a really important point here. When I talked about just enough virtualization, we're talking about not just how lightweight the VM is, but also a different operational model here. Because the point here is that on the left-hand side, you explicitly manage the VM, right? You create it, you install stuff into it, you make sure it's healthy over time. If something's broken, you fix it, you patch it. The thing might live for weeks or months or years, right? These VMs on the right-hand side are very different. They're created instantaneously, on the fly, whenever a container is needed. When that container is done, they go away. There's no human being manually provisioning that VM. The VM's created by virtue of an API call in a Docker, right? And that VM will only live for minutes, hours, maybe days, probably not weeks, right? Containers don't usually live that long. They're rolled over pretty quickly, typically. So again, a different type of virtualization. The VM here is not necessarily the first-class element. Really what you're talking about is the VM becomes kind of this transparent underpinning which provides security and operational benefits, but really what you're managing on the right-hand side there is the container. Or sorry, what the developer is managing, at least what the application is the container. But what you get is all the operational benefits within vSphere of seeing both traditional and containerized applications side by side. So that's a little bit of a subtlety there about the technology, but we think it's pretty exciting, right? A new form of virtualization to go along with this container use case, providing all the benefits, security, isolation, operational benefits, etc., of virtualization, again, with the best of what containers provide. So a lot of subtleties here. This is very different from any of the other announcements you may have seen from other vendors and so forth around what they're doing and combining virtualization and containers. This is actually really virtualizing at a higher level than the VM. We're virtualizing a container host. Okay, so that's cool. So now let's switch over to Photon platform. So again, I won't go through this too much because you guys have already seen it, but really when we talked about Photon platform, we were saying, you know what? Let me build this out here. You know what? We really want to target new use cases, right? Very high-scale software as a service type greenfield data center environments. And the idea here is you need a high-scale control plane, API-first model, really slimmed-down feature set, and also a new sort of economical model. We want to make it subscription-based, so you only pay what you use for, right? So we think there's a lot of opportunity to really rethink infrastructure in this next-generation world. And as I said, this is the Photon platform. And again, it's built from the ground up for these types of new use cases, really focused on APIs, on high scale, and but continuing to use the hypervisor underneath the covers. So let's, again, this next slide here, same slide you guys saw in the keynote, but I'll review it again just in case. So the core of Photon machine is still virtualization. Some people are like, oh, are you doing bare metal? We actually said, no, we think we can get all the benefits of bare metal in terms of speed with all of the benefits of virtualization. This is the whole just enough virtualization model. These VMs come up immediately, they're super lightweight, and they're destroyed when that container inside them is done running. That technology is still here inside a Photon machine. We use the core virtualization engine inside of ESX, the microvisor you might call it, and combine that with Photon OS. So again, a very simple, stackable, replaceable host. Now, you're probably going to have thousands or tens of thousands of these in any large Photon platform deployment. So there, again, you need something that can manage across all those hosts, can manage the 10,000 of them, as well as the hundreds of thousands or millions of containers that are on top of those things. That's where Photon Controller comes in. It's multi-tenant from the ground up. It's also very, very scalable, right? And able to avoid any single point of failure type of problems. So that means as you see these things, Photon Controller instances being distributed across the infrastructure, you can have these things individually fail, but overall they can still provide that single API endpoint for things to talk to. And as we mentioned in the keynote, we're seeing these frameworks like Cloud Foundry, like Docker, Hadoop. These are the things we talked about, right, in terms of structured versus unstructured platforms. These are the building blocks that developers are leveraging to really build out their next generation applications. So rather than managing individual containers inside a Photon platform, we're really focused on managing these building blocks themselves, the Mesos, the Kubernetes, the Cloud Foundry. That way, it saves you a lot of time and energy. You're not dealing with individual containers. You're dealing with a much bigger cluster. It's much easier to manage at scale. So this is the way it works. Now, in this picture, what you see, Photon Controllers, looks like it's on every single host. That's not necessarily the case. We'll have different sort of best practice routines. We may have sort of one Photon Controller per rack, or whatever. We'll figure out those specifics. But generally speaking, as you saw in the demo today, right, the developer or development organization will talk to the Photon Platform API. That API will provision frameworks for them, Cloud Foundry, Kubernetes, Jenkins, big data stuff, whatever you want. Those things will then be set up automatically. Photon Platform will handle all the VM creation under the hood automatically, making it super easy for these development teams to get up and running very, very quickly. Once they've done that, on top of that, they can then provision their applications using the native APIs of their choice. If you think this looks kind of similar to vSphere integrated containers, you're absolutely right. There's common principles at play here, right? You talk to a central API to create your framework, then you talk in the native API to that framework to actually get your work done. In both cases, we can provide strong multi-tenancy and isolation by leveraging this dynamic, just enough virtualization under the covers. Okay, so now let's move away from compute and talk about what we're doing on the network and storage sides. So when you talk about networking, and specifically container networking, there's a lot of ways of doing that, or there's a few ways of doing that today. So one way that we see actually happening quite frequently is that people run, again, multiple containers per VM. Within each of those VMs, they have various network settings and policies. They have NSX and so forth. They can configure all that. Now today, NSX can't go actually to the individual containers. Its termination endpoint is at the VM. So what you can then do is put all the containers inside a VM behind a NAT, do something like that, and kind of make it work. And this actually isn't a bad model, right? This is a very much workable model, but we want to do something a little bit better. So what we're looking at is how can we really provide two layers of network virtualization effectively. One at the hypervisor layer, and another one inside the VM, actually at the container layer. The idea here is that if you do run multiple containers per VM, then you can actually get all the same NSX benefits as you get for VMs. You can have specific firewall rules or routing rules or virtual networks for each of these containers individually. So this is a pretty interesting approach to it, and it's something we think can offer a lot of benefits. Again, what you're seeing here is a bunch of different options about how to do things. We'll kind of have a prescribed way, but we want to give customers a lot of flexibility in how they go and provision this stuff. One note on this one, by the way, some folks talk about, okay, do we still need a hypervisor and this whole, how does network security look in this new world? So here what we have are containers running on bare metal physical servers. Now, the issue here is that if a container is compromised, one of the big risks is that that compromised container, people can break out of it, get root on that system, and then take over other containers or other, in this case, hosts. The reason they can do that is because they get access to the physical NIC, they can put it in promiscuous mode, and then they are off and running, right? They can go find out other servers and see what they're doing and eventually go and attack some other application. So the power of what virtualization offers is that even if you compromise an individual VM, virtualization prevents you from breaking outside that VM, right? The hypervisor prevents you from setting your NIC in promiscuous mode. Maybe it'll let you do it, but it won't send you all the traffic on that network, right? It'll only send you the traffic you're supposed to get. Again, it understands those security postures and can automatically implement those. So again, we think the hypervisor is a really key area of enforcement here. That even if you are leveraging containers, you still want the hypervisor to do proper security, not just for networking, but just in general. So in the end, what we see longer term is being able to provide really powerful networking capabilities to both VMs and containers as first-class citizens. Kind of how vSphere integrated containers enables containers to be first-class citizens within vSphere. We're working to make the same thing happen within NSX. Now, that being said, keep in mind that vSphere integrated containers it means you can use NSX on containers with vSphere. Right? This is kind of a secondary or even additional thing that we're doing. Okay, so now let's focus on storage really quickly. So, lots of things happening with storage. One of the challenges that I don't think I really mentioned is that when you look at the unstructured space, or even the structured app platforms, storage is still somewhat of a challenge. A lot of containers are generally run stateless, meaning they don't save any data. And if they do save data, that data is gone if they restart, right? You can't assume it'll still be around. And yet, persisting data is kind of important, If you don't persist data, you're calling someone that does. If they don't persist data, they call someone else that does. It's kind of like the world on top of that stack of turtles. There's got to be a bottom turtle, right? Someone actually has to do the real work of persisting and saving data and then giving it back to the container or the application when it's needed. And you can see here, this is the left side here is Docker Hub, actually. You can see a few of the things are highlighted there. You look at these persistent things, MySQL, Cassandra, so forth. These things have millions of downloads, right? So a lot of usage out there of these technologies. Now, the way container volumes work, or volumes work within containers, I should say, is that you have a Linux operating system, virtual, physical host, either way. And what you do is you map portions of that file system inside the container. By default, that container can't see any of the file system outside of it. But what you can do is selectively map in specific directories. So those directories, are backed oftentimes by local storage, right? So this presents some challenges. How do you actually deal with data inside of containers? As I said before, if you just save data, just raw inside of containers, it'll be lost. All that stuff goes away when your container restarts. So we need some way of managing that storage on a longer-term basis. So what we've seen is, again, a lot of innovation coming out in the open source community. And one of these things is called Flocker from a company called ClusterHQ. So what they've done is provided a whole system to really provide persistent storage to containers. Now, they do a lot of stuff in terms of having a network proxy to send data between physical hosts and do all this kind of crazy stuff. However, when you're running on vSphere, you don't really need to do that. Because we've already done that, right? vSAN and vVols and VMFS and NFS, all the stuff is already there to connect shared storage between all these different hosts. So what we're doing is announcing a vSphere driver for Flocker to really optimize the provisioning of this persistent data to containers. Let's talk about how it works. It's actually not very complicated. It's pretty simple. So again, today what you have is you have a virtual machine running Linux. That Linux VM has a VMDK that has its entire file system on it. That file system is then mapped, part of it might be mapped, into the container to give persistent storage to that container. The problem now is that Linux VM is the only one who has access to its VMDK. So the data the container wrote is stuck on that, let's say, VMDK1 there, right? So if the container started up on VMDK2, it's like, give me my data back, and the OS would say, wait, I don't have your data. What are you talking about, right? It's back there on the other one. That's the problem. So now that container is now stuck to that virtual machine, which kind of defeats the whole point of containers. You want to be able to move containers around, right? So what we're doing with Flocker is doing something different. Again, very simple, right? Creating a separate VMDK for that container. The container actually gets its own VMDK in this model. And that VMDK will be hot added to the VM where that container is running. So this is what's coordinated between vSphere and Flocker. We handle all that. And as you start up that container, we talk down to vSphere and say, hey, give this storage back to that container. And so it knows the VM, and it'll map it into the VM. The VM will then map it into the container. The container's happy. Container starts up somewhere else. We'll redo that whole thing, map that storage where it needs to go. So again, this is the same problem that we've solved for virtualization. We're now solving it at another level of indirection, solving it inside that virtual machine. So this is, again, something that's out there today. So vSphere integrated containers will also solve this problem. Let me make it very clear, it will. As we talked about, vSphere integrated containers is in beta right now. It's not out there. This Flocker driver is available today. You can do this as we're showing here on the screen today with your existing installation. So if you have these problems today of wanting to provide persistent storage for containers and want to do that in a very seamless and easy way, this is the way we're recommending right now. Now, when vSphere integrated containers comes out, that will be the right thing to do because it'll be a much more comprehensive solution. Okay, so in summary, we have a lot of different things that we're doing. Again, I talked about it from left to right here. On the developer side, providing developers the best tools, the simplest tools to get their work done. We think that our enterprise-grade, mature hypervisor is a great thing there, and we're giving that out for free to developers. So if you have developers that are using VirtualBox and are cursing its name, say, hey guys, you can get App Catalyst for free. Great option. When you're talking about after the code's been written and checked in, this is where vRealize CodeStream comes in to really help automate that whole development lifecycle process there of testing it, staging it, getting ready for it to go to production. Again, leveraging all the existing tools you already have, Jenkins or Chef or Puppet or whatever CodeStream can layer on top of that. Then on the right-hand side, we talked about a number of things. We talked about the application platforms, how you have this choice between structured and unstructured and the different trade-offs there. But this is a good situation, right? There's a lot of different directions you can go, a lot of powerful technologies. Then we talked about compute, this notion of vSphere integrated containers, extending vSphere to engage with containers and cloud-native applications. Photon platform, a whole new application or infrastructure stack from VMware really focused on cloud-native apps. Both of these technologies will be built into vCloud Air, as we mentioned. I don't know if we mentioned that during the keynote, but we absolutely will be doing that. And finally, we talked about both network and storage and all the optimizations we're doing there. So end-to-end, we're doing a lot. Again, you saw all those other companies out there. We're not trying to compete with all these guys. We're trying to work with them. So folks like Mesos and Kubernetes and Docker, we think these things are great complements to this infrastructure that we're running here. So finally, I'll say that, as I mentioned at the keynote today, we have a tremendous amount of activity happening around cloud native at VMworld this week. So you can actually see the show guide down there at the bottom. If you haven't checked that out, I highly recommend you do. It's got all the breakout sessions listed. We try to group them for you so you can better understand where to go and when. We have this whole DevOps day that's going on, DevOps at VMworld. It just kicked off earlier today. It's still happening. A lot of workshops, a lot of great keynotes by recognized industry folks. We have our own breakout track, in fact, from the Cloud Native Apps team. There's a hands-on lab, something you should definitely check out to really kind of get a feel for what some of these technologies look like. I also mentioned the VMware video game container system. This is, again, kind of a fun way of playing around with these technologies. There what we have is basically running vSphere containers, vSphere integrated containers, running that with Photon OS and Docker, running a DOS-based game called Prince of Persia, which of course I'm sure you guys are familiar with. It's actually pretty awesome. It's amazingly addictive. I started playing it last night and had to cut myself off. So it's over in Moscone West in the hang space. We highly recommend you go check it out. And finally, there's a lot of stuff that's continuing to happen both this week and afterwards out on the community. We have blogs. We have our GitHub page, vmware.github.io. Please go out there, check out all those open source projects. As I said, we will be making Photon Controller open source as well. We announced that in the keynote. When we do, that'll be up there at vmware.github.io. So a lot of cool projects. We encourage you to go out there, check them out, follow us on Twitter. Thank you guys so much.